Good afternoon, everyone, and welcome to the session. This is Solve with Instructor for week 4 of MLT session. So, before starting, last time when we met in the last session, someone asked about the loss function of least square techniques, right? This is least square classification techniques. I think Rajiv asked that question. So that loss function was in whatever is taught in the lectures is not the correct one. There's possibly some mistake in the loss function because loss function cannot be a matrix anyway. Loss function is always a constant function, if a scalar function, but there it was given a matrix function. But it is not confirmed with. We haven't contacted sir about this, so till now we haven't made any changes in the slides and in the lecture. But for this sessions and we will take the loss function as the scalar quantity there, and we will define the loss function as a trace of that matrix, not the matrix itself. Okay, and you can verify that as well. You just take a simple example with one feature and add dummy features to that. Take two examples and just try to find out the loss functions in the form of expression and in the form of matrix. And you can verify that the trace itself gives the loss functions, not the matrix. Matrix doesn't make any sense for the loss functions. Okay, so should we start the session now? So you can keep your pull-up file ready for that, so that you can code yourself for all the tasks which is given here. So first, let me share my screen.
Good evening, sir. Are you going to share your screen now?
Yeah, I'm gonna share my screen now.
Okay.
Okay, so let's start. Can you see the screen?
Yes, sir. We can see your screen.
Okay, so first task will be here for the least square classification. We will start from the scratch and we will try to fit our model. We will create one very simple example that can be solved by the classification problem, and we will fit that example using least square classification problem. Okay, so this is your first task here. So you can import your libraries in your pull-up file. And there you need to create one example of the classification problem. That is, you need to create a binary. Please mute yourself. Who is speaking? Yeah, thank you. So you need to create two classes, and each classes must contain 50 points. And you should have that examples must have two features. Okay, now you can create those examples from the Gaussian distributions with the standard deviation of 2, and make the center of one class as 2,2 and the other class at 10,10. Try it, and then we will solve it. If you have any doubts regarding question, you can ask. Okay. So how would you create those examples? Anyone? Anyone want to answer this question? Am I audible?
Yes, sir, you're audible.
You're audible, sir. It takes time to write these courses.
Okay. So should I proceed or should wait for some time?
Maybe a minute more. Might help.
Okay. Okay, so I think guys, we should proceed now. So how you will create such examples? So here you need to create the classes should belong to Gaussian distribution with standard deviation of 2, and each class must contain 50 points. So what I will do, I will create some random numbers from the normal distributions with standard deviation of 2 and with the center at, or say mean at 2 and 10. And for every class, I need to create two features, right? So for one class I will create 10 such examples, and I will reshape them into 50 cross 2 matrix. So that matrix will give me points from the one class, right? So let's do that. First of all, let me set the random seed at a fixed number. So let's say x1 is coming from normal distribution. So first class should be at 2, 2. So I will create some examples with the mean 2 and the standard deviation of 2. And the size I will create is of 100, right? So it will give me my 100 data points from the normal distribution, but I need to make two classes. So I will reshape these points into 50 cross 2. This one will give me my one data point. So you can see how those looks like. First 5 data points will look like something like that. So these points, the points from the first column will denote the first features, and the second column will denote the second points. The points in the second column will denote the second features. Okay, so we have such 50 points. So this will denote my first class, or you can check the shape as well. So this is gonna be 50 cross 2. Right, so this is my first feature. Same way I will create the for the second class as well.
Excuse me, sir.
Yes.
So there's some kind of disturbance actually in the background.
From my side?
No, from my side.
Okay, so it must be my side because all are mute. Just give me a minute.
Sir, one question. We don't need 50, 2, right? Can't we just do -1, 2? Since we know there are 100 entries.
Yes, I think -1, 2 also will work.
Hello. Is it better now?
Yes, sir.
Okay. So I was saying that x1 will be my first class points, and the second I will same way I will create, but here I make the mean at 10 and standard deviation of 2, but I will create such 100 data points so I can make 50 to the first feature and 50 to the second feature. Right, and you can also say -1, comma 2 because we want 2 columns. Okay, so these x1s will be my first class points, and x2 will be my second class array of the second class. Okay, so yeah, so that's how the first class will be done. Any question here? Okay, so this is your second task. You need to make a scatter plot of these data points. This should be very easy, so do it quickly so we can move to the other tasks as well. Okay, so should we proceed? Are you doing these questions on your Palava or not?
Yes, sir.
Okay. So scatter plot will be easy. Use the you make the use of matplotlib library. So what I will do, I will create scatter plot. So in the scatter plot x-axis, what I will do, I will take on x-axis, my first feature will be on the x-axis, and on the y-axis, I will take the second feature. Okay, and I will plot each and every data point. So x1 will be from first data points. I will take each and every examples because each rows depend different examples, and I will take the first column of that. First column denotes the feature. So that is going to be my x-axis, and on the y-axis I will take from the same class. I will take each and every examples, and but from the second feature, and second feature is denoted by the second column of that matrix. Or right, and so this will give me the scatter plot. Yeah, so these are the points from the first class. You can see that my first points are centered around 2. That's what I want, right? And they are distributed with normal distributions and with the standard deviation of 2. This is for first class. I can draw for second class as well, the same manner. Now just need to create the same thing for each and every example I will create, but for the first feature I will take on the x-axis, and for the second features, second y-axis, right? So these classes will look something like that. So first class is centered around 2, and the second class is centered around 10, right? And both all contains 50 examples. So this is the scatter plot for our data set. Now you can see these are, we can apply classification problem to this. So our next task is to create the feature matrix. You need to create feature matrix level vector. Okay, make these class from the class 0 and these class vectors to class 1. Okay, and add to the dummy features to the feature matrix X and suppose those examples. So this is your third task.
So feature matrix, okay, this will come from the two libraries, right? What is that comment about NumPy library?
Sorry.
What is the hint about using NumPy library?
Because now you have to make one library. You have to use x1 and x2 data points, and you have to combine those data points into one matrix, right? So for combining those two matrices, use NumPy library. I need to use those examples, x1 and x2. And because I need to make feature matrix, I have to combine those matrix, x1 matrix and x2 matrix. For combining matrix, use the NumPy library. If you have another way, you can do that. It's completely your choice. So what will be the size of feature matrix without the dummy feature?
100 into 2.
Sorry.
100 cross
100 times.
Yeah, 100, 2, right? 100 examples are there and 2 features are there. So my size of feature matrix will be 100, 2. Shape of that matrix. Okay. So should we proceed, or you want me to wait for some time?
So you can proceed, I think.
Okay. So what function you will make use of to create to combine two matrices?
NP dot concatenate. I use that.
Yes. Yes. So concatenate will combine these two matrices. So how? Let's look how these functions work. So here we have x1 as the first class matrix and x2 as the matrix of the second class points, right? So I will, let's say x1, I will name the x to the final matrix. So I'm saying this to x1. So it will, I will use of the concatenate function. So what it does, it will, it takes two arrays. Let's say the x1 is first arrays and x2 is second arrays. So what it will do, it will combine these two arrays rows wise. So first in this matrix, what will happen? First rows of will be x1 matrix and the last rows will be from the x2 matrices. So it just type of stacking. Right. So this will be my x1 matrix. It will combine. So you can check that as well. So the shape of x1 will be 100 cross 2. And if you want to check the elements as well, take the first 5 elements of x1. So look at these first 5 elements. So these are coming from x1 matrix. So these are my first features. These second columns are my second features, right? And if you want to check the last, so look at these examples. So first 50 examples were from the class 1, and other 50 examples are from the class 2. So these are my examples from the class 2, right? So this that's how I created my feature matrix X. Now I need to create a label matrix as well. So label matrix, let's say your label matrix is Y. So same function I will make use of. So first 50, I know first 50 examples are class 0. Right. So what I will do, I will concatenate the zeros, right? So first zeros, and how many zeros I require? It's just the shape of x1 matrix. How many examples are in x1, right? Or you can directly, because I know ahead of the time there are 50 examples, so I can directly give 50. If you don't know ahead of the time, you can say there in x1 matrix there are 50 examples. So these are my array of the 50 zeros. Next 50 examples belongs to the class 1, so I will create an array of the ones. So this will be my Y label vector. What happened here? Okay. What is wrong here in this case? Yeah, so this is my Y. You can see. Now this is my column vector. First 50 examples belongs to class 0, and next 50 examples belongs to class 1. So look at these examples. These are float values. You can check. You can change the values as well in the integers. And now they have come into the integers. So this is my label vector, and this is my feature matrix. Now I need to add dummy features to X, right? So if you, let's say your X1 something looks like that. So now first column must be all buns, right? So I need to add, let's say X is that. So what I will do, I will make use of concatenate function again. So concatenate functions add row wise, right? So what I will do, I will make first how many 100 examples are there. So I will convert np dot buns. That are my these are my array of 100 cross 1. But I will, if I transpose it, So this will be my 1 cross 100 matrix. So this is 1 row. Okay, so 1 row I will add with the rows of, I will transpose x1 now. So what this function will do? Now, what will be the, what do you expect the output of this x now?
2 into 100.
The shape of x will be what?
Sorry, 3 into 100.
3 cross 100 is that?
3, yeah, it will be 3 cross 100. 3 rows will be there. First rows will come from np dot punch. Here it is, and the 2 rows will come from x1 transpose, right? X1 has 2 columns, so x1 transpose will have 2 rows. So it will concatenate those rows to this row, right? Now I will transpose all the matrix. So I will get the feature matrix, right? Okay, so this is my this matrix is my column matrix. So I have to reshape it to the row matrix. So 1 row and how many columns it will automatically decide. So again, some problem is there. What's going wrong in this one?
Well, right now you're just adding dummy feature, right?
Yeah, we are adding dummy features to x.
So can't we do it directly to x1? Like we can use a column stack as well, I think.
Yeah, that also we can do. So I want to make use of concatenate functions.
Okay.
Axis equal to 1 you have to put, no?
Sorry?
Can't you put axis equal to 1 instead of transpose?
Sure, why are you reshaping it? It's just, we need to just transpose it again, right?
I
No
need to
need to
make it.
reshape.
I need to make it the row matrix.
So
No, it
concatenate,
is now 3 cos 100. You need to make it 100 cos 3, right? You need to
Yeah,
just
100 cos
transpose
3.
it. You just need to transpose it. Don't need reshape, I think.
concatenate needs a square bracket, right?
If you
Not
just
actually.
remove the reshape, I think it should work.
So I think these brackets are creating problems. Yeah, what you were saying by we need to, okay, why need to transpose? Yeah, you were right.
No, sir, no. You just created np.once 100, which is 100 into 1 matrix, and you are transposing it. It becomes a
1 cross
1
100.
into 100, 1 cross 100, and then you are concatenating the transpose of x, which is now a 2 cross 100, right?
Yes.
So they are not matching. I mean, their shape is not matching. If you want to add matrices along the axis, there you are adding the shapes to match.
And now it will work. Now look at the x1 first. So what we were doing, we were just making the transpose of np1s that we need not to do, right? We just reshaping because np.1 will give you the column matrix. So I need to make it the row matrix of 100 cross 1 comma 100. That is 1 row or 100 columns, right? So look at this x matrix now. Now every column is 1, and this is my first feature. This is my second features, right? So any confusion in this formula?
Okay, understood. The dot transpose doesn't work on one-dimensional matrix, so you have to use the reshape option.
Yeah.
Okay.
So that's what the problem here. I was making the transpose that was wrong here. Okay, so got this point. So what it will do, it will take the row of first this matrix, that is first row, and then will take the rows of x1 transpose matrix. So x1 transpose matrix has rows, that is column of x1, right? So then I will transpose the matrix that I will get the feature matrix. So x is my now feature matrix. You can check the shape as well here. Now the shape will be 100 cross 3, right? So this is my x now. So I have feature matrix, I have level vectors, I have dummy features. I will just shuffle these examples just to sake of so that these are different examples are belonging to different at different positions. Okay, so what I will do, I will just create a sequence of random numbers, right? Okay, so how many numbers will be there in the sequence? 100 number, because I need to shuffle 100 examples. So this will give me the a permuted sequence of 100 integers. If you pass the any sequence in this argument, then it will give the another permutations for that sequence. But if you pass the integer here, then it will give the sequence of numbers from 0 to that number, up to that number, that is up to 99, right? So permuted sequence will be given here. So my x, so let's say this is your x2. Okay, so this is your x2, and x will be my final matrix. So this is x2, and your indices will be from there. So it will shuffle my matrix, and I have to shuffle the by as well, right? With the same sequence. Now a will so my label output and x will be changed. So x, now you can say that x, examples of x means look at this. Now look at the second examples. If you look, this is 11 point something and 12 point something. So definitely it is coming from the second class, and the first example is coming from the first class. This is coming from the first class. This is coming from the second class. This is coming from the second class. So these examples has been suffered now. Or if you look at the Y shape as well. So let me print this. And if you print Y as well. So what output do you expect here for Y?
Random 0, 1.
Yeah, so look at this example. This is class 1, class 0. So it Y must have 0 and then 1, then 0, 0 and 1, right? So let's check it. So 0, 0. Okay. Random, we haven't set the random seed there. But they are giving different examples now. Every time they are giving, we are getting different examples, right? So I think for here, we have to set the random number. And now this is okay. Look at this example. This is coming class 1. So this is class 1. This is coming from class 1. This is class 1. This is coming from class 0. So this is class 0. So we are all set now. We have feature matrix. We have level vector with itself. Okay. So what the next task will be? You need to encode those level vectors. Remember, in the classification problem, we have to encode level vectors in because there now we have scalars associated with each examples. So we have to encode using one hot encoding. So every example now will be is associated with a vector quantity. And what will be the shape of that vector? That's gonna be a column vector of size 2, because we have only 2 classes, right? So encode your matrix by. This is your next task. You can make use of other functions as well as stack, vertical stacks, all other functions are there in NumPy libraries. So you can make use those as well.
Sir, what is the next task again? Sorry, I didn't. Encode.
You have to encoding the level vector by using one hot encoding.
Sure, I have a doubt.
Yes.
Sir, if you can print the label vector, it
Yes.
already has zeros and ones in it, right?
Yeah.
So it already classifies for a binary classification. So why do we need to one hot encode it again?
Okay, so in a binary classification, always remember that you have to encoding your label vector using one hot encoding, otherwise it will not work. Remember, if you have done that for each and every class, you have to create, if they are k classes, you have to create k class discriminant functions simultaneously. And if you want to discriminant function for two different classes, just differentiate those discriminant functions, respective discriminant function. That will give you a discriminant function for those two particular classes. Okay, so in the case of this, it will look similar. The discriminant function will look similar to that we generally do. That W0 plus W1x plus W2x2, something like that. Okay.
Okay, sir.
One thing as well here, we have to make those integers. Okay. Because we want the output to be integers. Yeah. So and initially these were the float types. Now they have come into the integers type.
Sir,
Yes.
then the encoded matrix should have the size of 100 cross 2, right?
Yeah, 100 cross 2.
Okay, sir.
Okay, so this I think we have already done in the last session. So how will you do this?
I will create an identity matrix of 2 by 2,
Yes.
and then I will convert the y vector into an int type vector because I have to use it as an index. Then before that I have to convert it as int values,
Okay.
and then I will use the identity matrix sliced by the use the slicing of y.
Yeah, exactly. Someone has written in the message. Okay, so let's do that. So you need, so I can create first the identity matrix of the size 2 because we have two classes, right? So if you look at the E here, okay. So if you look at the E here, so this is your identity matrix of size 2 cross 2. Now, if you check the by, if you paint by here, okay. So this is your one. So for one will for first example, the output will look like the matrix of 0 1 because the corresponding class should be 1 and other classes should be 0. Okay. For second, it must be 0 1, right? So for first examples, your the output will look like that first row of that identity matrix, right? And the second example will be the second row of the identity matrix, and third example will be your first row, that is 0th row of the identity matrix. So that's what I will do. My by encoded will be now. This is by with the E, right? Yeah, one thing here, I forget that you have to convert into the integers because I have to make use of indexes.
Sir, you have to convert the y vector into integers.
Yeah. Okay. This is by.
No,
Why
sir.
I
You have to convert the y vector into integers, not the identity matrix into integers.
By I've already converted by matrix into integers.
Okay.
Right. So my by encoded will be 0 1 1 0. So look at by here. First example is from the first class, zeroth class, first class, first class. So look at the 5 example. This is your first class. This is first class. This is zeroth class. This is first class. This is first class. So all it's set now. This is your encoded matrix. Okay. Now we will make use of this label output for our next classes. Okay. The fifth class is very easy. You have to just split the data into training data set and the test data set in the 4:1 proportions. That is, there are 100 examples. So in the training examples, you need 80 examples, and in the test examples, test data set, you need 20 examples. So it's just the splitting of the, because we have already supplied our examples, you just create two different matrices for training and for test. For both you can do for pictures and for full level metrics.
Sir, if we were to use the sklearn preprocessing library, can we do that at the very end of the lecture? I just want to understand.
sklearn that we can do MLP session.
Okay.
Sir, from now on, will we only work with the encoded version of y, or the y vector, the raw y vector will also be
by
required?
encoded we will use.
Okay.
So can you show the code for one-hot encoding? sir.
Okay, so this task is very easy. You need not to do anything here. Just take first 50 rows. Okay, so X training data set will contains the first 80 rows of X, and the next X no, for test data set I will next 20 rows I will use for X testing test data set. Similarly for by train and by test I can do. So this will give me my training data set and training data set and the testing data set, right? You can check this as well. Yeah, so training data set will look like 80 cross 3, and by training set will look like 80 cross 2. For testing also you can check. So I think there should be no problem, and we have already shuffled our example, so we need not to shuffling as well. Okay. $90 or $20? How many were in the training? 80, right? Okay, we
Start
create.
from 80.
Yeah, 80 won't be there. And now it's all set. So this is your X train and X test, by train and by test. Okay. So should we move, or you want some time to come to this point? Up to this point, now we will do modeling. Now we have data set, we have feature metrics, we have level output, we have training data set, training output, test data set, test output. So if you haven't done till now, you can take your time and come to this point. Then we will do the modeling. Take 2 to 3 minutes.
Sir, can you explain the encoded part? Because I had issues with the code that Sir was showing in the video, so I wasn't able to understand the one hot encoder wala code.
So this code you want me to explain?
Yeah, in fact, also the one that Sir uses with decorators and getters and setters. I
No,
wasn't able.
this is the same code. The sir used the same idea there.
Okay,
in
yes,
the
yes,
in the
sir.
class method. Okay, so what's happening here? Look at your by. So by has class 1, then class 0, then 1, 1. That's just your first example belongs to class 1, right?
Mhm.
So for now, this is scalar. You have to convert into the column matrix, right? Column vector of size 2, right?
2.
So how the output of this example will look like?
0, 1.
0, 1, right? So look at the identity matrix here. So this is your identity matrix, right? So
Yes,
you want
yes.
your first examples should contain the row of the identity, second row of the identity matrix, or first row, right? This is 0th row. This is first row. So first example should contain the first row of the identity matrix, right?
Yes, 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 sir.
If you look at the third example here, your third example belongs to class 0, right? So output, its output will be 1, 0, right?
Yes, yes, sir.
So your third example should have the row
One
zero,
of the.
0th row of the identity matrix.
Yes, yes, sir.
Right. So what I will do, I will just take by encoded E with the this indexes or by. So what it will do, it will take the rows of identity matrix with this index. So by has in the first rows, it will be the first row of the identity matrix. In the second row, it will be the first row of the identity matrix. In the third row, it will be the 0th row of the identity matrix, right? That's what we want.
Okay, okay. Yes, sir. Yes, sir. Okay. And when we have more than 2 classes, we just change the identity matrix.
Yeah, identity matrix.
Okay, okay. Sir, but decorators was also not clear. If you have that, can you explain maybe?
No, last session I used the decorator collab as well, but sir has used the same code, same idea there. Just go through that once, okay?
Okay, yes.
Sir, when you use the sklearn library for the train test split function,
Okay.
does it randomize the examples before splitting it into 2 halves, or they take it sequentially?
Depends what output you're providing, what input you're providing. It takes only, it is shuffled internally. And once it is shuffled, it will give you
I'm asking because I'm using the.
Yeah, it's completely okay. If you have used SQL library here, you have been given X train now. Now we will using that that feature training matrix here, right? Once it is fixed, you just rename by X train or by train. Okay. Okay, so I think we should move now to the other tasks. Up to here, it should be clear. Okay.
Sir, why did we convert the identity matrix to integers?
Because I want outputs to be 0, 1, not 0, 1.0, 0.0, something like that.
Okay, okay, got it. Sir. Thank you, sir.
Okay. So this is your model. Now you have already seen the data. It's looking like that. So you need to make a linear discriminant functions here, because we are gonna do the classification using least square classification here. So you have to design a linear discriminant function here, and you have to learn the parameters of that. So we have 2 classes here, and we will learn 2 discriminant functions simultaneously. So your functions feature matrix is of size n cross n plus 1. N examples and M features. So 1 dummy features are also there. So you need to learn total of n plus 1 cross k weights, right? So in this case, we have 2 features and 2 classes. So how many weights you have to learn? 3 cross 2, 6 weight vectors you have to learn. Okay, so weight matrix will be a matrix of size 3 cross 2 in this case. Okay, so this is your model, and your expected output, your predicted output will be in the form S into W, that we have already seen in the previous lectures. Okay, so this is the predicted values for the predicted outputs for a given feature matrix. Okay, so your next task is to predict the feature output. Okay, label output for the feature matrix X. Make use of the functions predict XW. You have to define a function XW that takes 2 argument X, that is a feature matrix, and a W weight vector. So if you provide these 2 arguments to the predict function, then it should return the predicted level for X. Okay. So this is your next task.
Initialize the main vector, right?
You can take a random vector just to take how the functions is working.
Okay, sir.
Okay, so let's do this. So you just need to do what you need to do. What you will do here, it's very easy because for functions you have been given the arguments x and w, and you will have to return the output matrix by. So you just have to multiply the matrix multiplication of x and w. That's it. So functions predict takes two arguments, features and weight, and z I will say the features into weights, and the return will return the maximum argument. So what it will do, it will give you. So if you return z, then it will give you the encoded matrix, right? Encoded matrix. But if you return the maximum argument along the axis 1, that is along the average row, so what it will do, it will give you decoded matrix, decoded output. So this will be your decoded output. So clear why I'm doing argmax for this z? I'm returning, I will get back the decoded matrix, not the encoded matrix. Okay, so what this function does, this NP argmax does, if you set x is equal to 1, then it will check each and every row and will give you the index at which the maximum values occurs. So remember, in the case of training data set, we have already two values, 0 or 1, and each and every rows will contain only one values that takes value 1, right? So that will be your maximum, and that indices will be your class indices. So that's why I'm interested in the index at which the maximum occur in each and every row. So let's say you can take a random vector w. I'm just randomly taking a random vector w. This will be my 3 cross 2 vectors, right? So I will use. So this is my just a random weight vector for this random weight vector, and I will make use of X training data set here. So what will be my predict values? So for these weight vectors, you can see each and every examples have been classified as class 0. Only one example has been classified to class 1. All other example has been classified in the class 0. So this is very random vector weight vector. That's why this is happening. Okay, in that predict function, if you only return z, then you will get back the encoded matrix. Okay.
Sir, here, can you please, not understood why the shape is 3 cross 2 of the weight vector? It should
Okay,
be
so
1, right?
Sorry, 3 cross 1.
1
okay,
cross
so
3, 1 cross 3.
So if you have 3 classes, if you have 2 classes, right?
Yes.
So if you have k classes, then you will learn k discriminant function at a time, at the same time. Okay, and each and every discriminant functions will take m+1 weights.
Okay, right.
Okay, so in this case we have 2 classes, so you will learn 2 discriminant functions at the same time, and each and discriminant functions will take 3 features, including the dummy features. That's why we are learning 6 weight here.
Got it. I recollect now that we have encoded it. That is why 3+2. Got it.
Yeah. Okay. So this function is done.
So just 1 second. Just 1 second.
Okay.
Sir, what's the argmax doing?
So argmax is doing it takes the 2 inputs. One is the matrix or the array, and the second is the axis at which you need to find the maximum indices of the maximum value. If you want set axis to any value, then what it will do. So if you don't set axis to any value, then it will take the maximum value in the array. Okay, and will give you an integers, will give you the indices of that maximum value. Okay, but if you set axis equal to 1, then what it will do, it will check each and every row.
Right.
I'm muting yourself because lots of noise in your background. Okay, so it will give you the matrix, and it will give you a vector actually. Okay, so each entries will denote the index at which the maximum value of that corresponding row will occur. Okay, and why I'm doing that? Because if you remember, in our label output, we have each and every rows have only one values, that is 1, right? And all other values are 0. So that will be my maximum value, and corresponding column will be my class, right? So if you see here.
Sir,
So,
but what we will get as a result from X cross W will not have that kind of structure. No, can you print Z once?
okay, so let's print. X string. Okay, so let's say X string times W. Okay. So this will something, it will look something like that.
Okay, sir.
Okay, I have interpreted it in wrong way. Okay, so what happens there? The maximum value of that will goes to that classes, right?
Yes,
if you have remembered that in from the show me that class percentum slides. Let me check where it was. Just give me a minute. I come. I just see where it is. Then I will show that. Okay, so can you see the screen now?
Yes, sir.
So it says it assigns label by k to example x if by k is greater than by z. So what happens here? So it calculates the value of this one, that is w cross w times x. Okay, so for which discriminant function it takes the maximum value, it assigns that example to that class. Let's say third example, it takes the maximum value for the third example, then it will assign the label 3 to that class, to that example. Okay, so that's what happening in our case.
Sir, can you also print the argmax of this x train into the
definitely. So what's happening here? This is values of first discriminant functions from the first discriminant functions of first example, and this is from the second example. So which class we will assign this class 0.
0.
Okay, so what it will do now? So if you apply the argmax function to this matrix, this features times weight, right? So it will check in each and every row. I have set axis to 1, so it will check each and every row. So it will check this this row and check at which index the maximum occurs. So maximum occurs at the 0th index, right? So very first entry of this function, whatever this will return, the very first entry will be the 0, and the second entry will be what? Now look at the index. Now it will look at the second row and will check where the maximum occurs. The maximum occurs at the 0th index. So it will, the second entry of this function will be the 0, 0, right? And now this will look in the third axis, third row. The similar way it will do. So if you apply the argmax to that, so let me do that here.
So this is kind of like a confidence ratio of each and every table class.
Let's say this is your Z1. Sorry?
This is kind of a confidence kind of a ratio right now.
Confidence in ratio means what?
As in the higher confidence we are.
Yeah. So it's actually denotes the probabilities. If I say probability, it won't be wrong because you will say that the probability is going greater than 0 or coming in negative as well. But if you will see in the next lectures that somehow it denotes the probabilities of occurrence. Okay, in that class. Okay, so look at now. So it will so first entry of that will be what? So if I want to print the Z as well, let me print Z. Let's print first 5 entries. Okay, let's print the 3 entries. So this function, what it will do, it will check the first row and will check at what index the maximum occurs. So maximum occurs at 0. So it will return 0. Now it will check the second row. Will check where the maximum entries occur, maximum value occurs. So it will occur at 0. Okay, so it will occur at 0th entry. It will give you 0. If the second, so you can verify that this for this examples, the maximum value is occurring at the first column. Okay, I'm saying this is to be 0 column and this to be first column. So that's what maximum argument this function does. Is it clear now?
Yes, sir. Sir, I have one more doubt.
Yes.
Sir, can you show me the part in the code where we ask the model to train on more than 1 weight vectors? So here it is learning on 2 weight vectors, right? Where does that happen?
2 weight vectors. Here weight matrix has the size 3 cross 2. Sorry, 3 cross 2, right? What's your question?
Yeah, sir. The dimension has one aspect, no k, which means these are 2 separate models of sorts getting trained, no?
So yeah, at the same time. Yeah. Just look at this. If you have k classes, then you will learn all such k discriminant functions at the same time. Okay, if you have only 2 classes, you are learning these weight vectors. So in the weight matrix, you will have one W10, W11, and in the second row you will have W20, W21, W2. Okay. So W1 vector will be what? It will be something like W11 and W21. Okay.
Yes, sir. So I wanted to find out how we are learning the weight vectors.
How we are learning the weight vectors.
Yeah.
So for that, I need to define loss functions. This is my model only. I have just defined my discriminant functions.
Mhm.
Now I need to so for two classes discriminant functions, you can take the difference of for those discriminant functions. I think sir has mentioned somewhere here. So decision functions, the decision boundary between two classes by k and by k will be a hyperplane, and that hyperplane is given by this. Okay, this is your hyperplane. Just subtract by k and by z from here. Okay, so this will be if you subtract for in this case, if you subtract by 2 minus by 1, so you will get a hyperplane. In our case, you will get a line, right?
I didn't get this part, sir. Can you explain again?
So what I'm saying, if you have constituted k discriminant functions, now you need to you need to define a decision boundary between two classes by k and by j. For that, you just subtract those discriminant functions. So this will look something like that. So this will be your hyperplane in m-1 dimensional space. Okay.
Yes. Okay.
Okay. So now for learning those, first you have to define the loss function. So how do you define the loss function? So this is done. Up to here, it's okay.
Sir, before we proceed to the loss function, I have a doubt. The collab file that was shown in the lectures and you went through in the last live session had
Yeah.
two predictions. One was predict internal and one was predict.
Yeah.
So just now the prediction that we have made, which one is that?
This is predict.
Okay, this is predict. All right.
Yeah. Predict internal was that with the encoded.
Okay. Okay, but the loss and all the other subsequent functions used only the predict internal output, right?
Yeah, internal output.
Okay, thanks.
Okay, so this is all done. This. Yeah. Okay, so you're not so your loss functions is defined by trace of this matrix. This is your actual output, and this is your x into w. This is your predicted output. So difference is the error, and it's the squared error. So in the vectorized form, this is error, transpose error, and we will take the trace of this matrix. And this is your that's how the error function loss function is given. In the slides, it is given the matrix itself is a loss function. Matrix is never a loss function. Plus loss functions is always a scalar functions. Okay, so trace of this matrix is given as the loss function. Now you need to
Why trace?
okay, so you can check it also. So do one thing. You just take two parameters, one feature. Okay, in the one feature, how many parameters you have to learn? And just take two classes.
And one feature
W0
then
and W1 for each class. No.
Okay, just give me a minute. I just show you what. Okay, just give me 1 minute. So can you see the whiteboard?
Yes, sir.
Okay, so just do one thing. Your loss function is defined as y minus x w transpose and y minus x w and the trace of this matrix. Okay, this is how you define your loss function. So what you do, just to for verifying, just say you have two examples and one feature. So your feature matrix will look like one upon x, one x1, one x2. These are your two examples and one features. That is, this is your one feature. Okay, and this is dummy feature. Now this is your x matrix. And do one thing, you have only two classes, so the bed vector will look like w01, w let's say 1 1. For this is for first discriminant function. For the second discriminant function, you will have w02, w12. So this is your weight vectors. Okay. So and you can assign some output to this. Let's say output is 0 and 1. So what will be your error function in this case? What will be the error? So discriminant function will look something like that. w01 plus w11x, right?
X1.
Yeah, for x1. So x1 minus output, exact output, so 0. This is error square. So plus something like that, w02 plus w12x minus the actual output. This will be your matrix. So you can check the matrix of this matrix. You just calculate this matrix y minus xw trace transpose and y minus xw. Check whether this is coming equal to this or not. The trace of this. Okay, so it will come some similar to like this. That's how you can verify your procedure. Actually, the loss function is given by the trace of this matrix, not the matrix. Okay, always remember loss function is always a scalar function. Okay, scalar function of weights.
Okay, sir. Understood.
Now let's look at your next task.
Sir, can you show that once again, the board? I still didn't get why this is getting called the trace. Trace is supposed to be the sum of diagonal elements, no?
Yeah, sum of the diagonal elements. So that's what I'm saying. Just verify this whether these are coming or not. This is gonna be your loss, right? Sum of a square function. Sum of the square of error.
Yes, sir.
Okay, so that is gonna be your error function. Just check whether this trace of this matrix is given this thing or not. Okay.
Okay. So nothing has changed. It is just a way of writing, right?
Yeah.
Okay, thank you, sir.
Okay, in the vectorized form, you can write this thing as this trace of this matrix. Okay.
So the weight, I suddenly got confused slightly. So the weight is the encoded labels, right? Or
Weight the.
Somehow I couldn't find the fact that did we compute the weights for this? We computed we got the training set.
No, weights are not encoded. We only encoded the output by.
Yeah. So did we compute the weight vector this step?
Sorry, can you repeat?
See, when did we come? Because I was looking at the task, I couldn't find the task to compute the weights. So did I miss something?
No. I'm just saying that you just try to find out this trace of this matrix. Now here by will be something look like that. 0 1 1 0. Sorry, 1 0 0 1. Right. This is your output. Right. So by matrix will look something like that, and x is your this one, and w will have something like this 2 cross 2 because two features are there, two classes are there, and one features is there. M1 plus cos k, right? So error, what is error? Error is defined by the predicted output minus the actual output, right? Actual output is, in this case, for this example, is actual output is 0, and the predicted output is this one. So this is your error for first example. For the second example, This is your error. This is the actual output, and this is the predicted output. Okay, so this is error for the second example, and the loss is defined by sum of squared of error. So this is your actually the loss. Okay, so I'm saying that just compute, just find out what this matrix gives and find out the trace. So I'm saying that trace of this matrix will be this. So loss is defined by trace of this matrix, not the matrix itself. Does it make sense?
But sir, if you take this, your vector is 2 cross 2 and weight is also 2 cross 2. So when you do x and w, okay,
Okay.
broadcast, then it is going to give 2 cross 2 matrix, right? But
Okay.
level is 0 1, then it is only a 2 cross 1, then it will not fit, right?
No, in this case, why you have to take this matrix?
Okay, that means you are telling you have 2 levels, right? That means you are taking 2 different values, correct?
No. This I've just calculated by my about how I define my error. Error I'm defining by the predicted values minus by the minus actual values. Okay. So
but if your x and y is 2 cross 2, then your error also be this y minus x w is also going to be 2 cross 2 matrix, right? As per your example.
yeah, 2 cross 2, and you need to find this trace of this matrix.
So you're telling 2 cross 2 transpose, then 2 cross 2. Then you have the transpose.
Again, you will get 2 cross 2 matrix and take the trace of this matrix. That's gonna be a scalar, right? Sum of diagonal element. So that will look something like that. Clear or not?
Sir, earlier we used to let it be a matrix and then differentiate it, no? Even now we will
So
differentiate
that is
only.
that is wrong. Matrix is never a loss function. Loss function is given by the scalar function. So okay, so let me clear this all. And so what's your task here is that I'm saying you have only one feature and 2 examples, right? And so my first examples belong to class 0, and second is just I'm making some toy data set. Okay, so one example feature matrix will look like 1 x1, right? First feature. The second feature will be second example will be 1 cross x2. So you have only one feature. Now this is your y. So how you will predict for first example? First, your discriminant function will look like w01 plus w0 w11 x, right? And for this one will be x1. So this is the predicted values for first example, and the actual value is 0, right? So this is your square of error. For second example, you will have w01 w02 plus w12 x2, and what is the predicted value? It is actual value 1. So this is your loss. Okay, what I'm saying, just check the values of x, w minus y. So by here I will use the encoded matrix, right? That's what I how define my loss function. So here you have to compute what 1 minus x1, 1 minus sorry, not 1 minus. This is your 1 x1, 1 x2. This is your x. Your w will be w01, w11, w02, w1. This is your xw minus y will be what? In this case, it will be 0, sorry, 1 0 and 0 1, right? If it is 1 1, then it will be 1 0 1 0 1. If it is 0 whatever 1 0, so it will be 0 1 0 1 0, something like that. So in this case, it is 1 0 0 1. So this is what xw minus y, right? You have just compute this thing, take the transpose, and then again multiply this thing. Let's say this is it. Okay, so that this will be a 2 cross 2 matrix, something like that. Take the trace of this. The trace will be this thing. Okay, just for verifying that.
So the trace is actually coming 2 times this thing. I just calculated it.
2 times this is. So that's why I
Yes,
defined
sir.
loss function of 1 by 2 trace of
Yes.
xw minus y transpose xw minus y. Okay.
So we will let y be in the encoded form only.
Yeah, by whenever you are calculating vector response, this y must be encoded.
So if it is a
This is the first
multi-level regression, okay, instead of 0, 1, if I have some real value, in that case also we need to track, or it is only applicable for labeling, even it is a 0, 1, or
No, this is only for this. This is only for classification problem.
Okay. Thank you.
So now I think it should be clear why we define loss function in such a way. Okay.
Yes, sir. Sir, someone was asking. So I thought even multi-class regression was like this. It's not like this.
Multi-class regression.
Yes, sir. I thought instead of having 0, 1, 1, 0, that will just have real values.
No, multi-class regression we don't encode, do we?
We don't encode, but there are multiple outputs. No, output is a matrix again.
Yeah, okay, then what?
So would you treat those as completely separate models? I think there was, sir also mentioned one case where all of them were trained together.
Okay, just let me think about it. Okay, so I'm not completely sure about this. I will confirm about that. Okay.
Yes, sir. Also, I wanted to find out. Now when we were printing Z, where did the value of weight come from at all? We haven't learned that yet. No.
No. I just randomly picked a weight vector this time.
Okay.
I just randomly picked one weight vector just to show how this predictive function will give. That's why you can see here all the examples are classified with 0 in 0 class. Only one example was classified in the class 1. While we have 50 examples from class 1 and 50 examples from class 0. Okay.
So this is the first iteration of the model learning.
Yeah, first iteration, just a random vector. If you do optimization using iteration, then you have to randomize, start your weight vector. Okay, mostly we start with the 0 vector. Okay, and in the normal equation, you need not to just starting your W. You just calculate this value. What normal function do is just take the derivative of this function with respect to W and set it to 0, and from there it finds the value of W. So from the normal equation, your W comes out to be X transpose X inverse and X transpose Y. Okay, so your next task is, okay, up to here we have calculated, right? This was this one we have done or not? Loss function we haven't done, right?
Sir, we are still looking at the whiteboard.
No, sir, we are not done loss function yet.
Now can you see the screen? Cola file?
Yes, sir.
Okay, so now you have to find the loss function. Loss function takes it will take three parameters: features, labels, and weights, and just define a function that will give you the loss for that given parameters. Okay, so you just have to write this expression. Okay,
Which means this last function will also call predict in the background.
Loss function will give you the loss.
No, I'm saying you should call predict in the background, right? Or
no, you cannot, because here we have write in the form of decoded form, not encoded form. Here we will make use of encoded matrix. Okay. If you will call it, then what will happen? For X, it will give you this array. It will return this array. But what we want just XW, not this array, right? That's why you cannot call that predict function.
Okay, this is where the internal predict internal function will come in.
Yeah, but there we use predict internal function rather than predict function. Okay, so you just write this expressions using NumPy library. So now we will do quickly because it's already 4:30, 5:30.
So just one question. In generally,
Yes.
in generally when we are doing for classification in means lot of books, if you see, they are teaching mostly this cross entropy. So we are going to learn, or we are going to use this least square classification.
No, we are using another techniques as well. Logistic
Okay.
regression, SWM, decision tree, all we are gonna cover in the coming lectures.
Okay. Thank you. Yeah.
Okay, so let's go. Okay, one thing always remember, just calculate a pseudo inverse rather than inverse, because sometimes what happens, X transpose X may be not full rank matrix. So in this case, inverse will not exist. So always calculate pseudo inverse. Even if it is full rank, pseudo inverse will give you the inverse. Okay, so always calculate pseudo inverse. Okay, what we haven't come till here. Okay, our task to find the loss functions. So what loss function, how you will define loss function? So loss will take 3 parameters, features, labels, and weights. So error I'm defining as just by minus xw. Okay, so this will be my labels minus features times weight vectors. And I will, what I need to return, this function should return the trace of E transpose E, right? So this will, np dot trace will return the trace of this matrix, given matrix. So this is E transpose times E and the trace of this matrix, right? And times half. The half is already there, so times 0.5. So this function will give me the loss function, right? Okay, so I can calculate this loss for this W that we have initiated, right? So xtrain I will use as the feature, pytrain I will use as the labels. Now remember, pytrain is in the encoded format, and W that we have initiated randomly. So for this loss function, you can check this much error is coming, this much is loss is coming, and that you can check here as well, because almost all the that examples have been classified into class 0. That is completely wrong. That's why the loss is coming this much high. Okay.
Yes.
Okay, so now let's move to the optimization procedure. You have two procedures. One is normalization. Second is using iterations problem. That is gradient descent. So in the optimization problem, in the normal equation, you just set the derivative of loss function with respect to W equal to 0. So derivative comes out to be X transpose by plus X transpose XW. This is derivative of with respect to W of the loss function, and if you set equal to 0, then you get the W as the X transpose X inverse times X transpose times by. Okay, so this is your weight vectors. Now you need to define a function fit that takes two parameter features and labels, and that will give you the learned weight vector, that W weight vectors. Okay, using normal equations. So it is pretty easy. Again, you just need to define a function, just take parameters, features, and labels. So you need to write this. The function should return the something value that should be in this format, in this equations. So do this quickly.
This is same as regression, right? Just a
Yeah, the same as regression.
feature at LB. That's all, right? So,
yeah, that's it.
Sir, is it true that we can't do pseudo inverse or inverse for big matrices, and that's why we do gradient descent?
Gradient descent, this is just a different method for finding the local maxima, local minima, or global minima. Okay, actually, what we are doing, we are just finding the minimum point of that loss function, right? So we have two methods. One we have already done in the mathematical class. If you remember the derivative, you just take the derivative set equal to 0 and find the critical points, right? So that critical points gives you the minimum points. So this is the normal one, normal equations. You just set the loss function, derivative of loss function equal to 0, and check at what values of w that minimum will occur. Okay, there's another way how to, whether it will be minimum or maximum, but we won't go in such way, because loss function will in the convex loss function you will always find a minimum point.
Sir, I have
Okay,
a question.
Yes.
Sir, in case of trace, the same derivative will apply.
Yeah, this happens for the trace itself. This derivatives is only for trace.
Okay, so in case of a single weight vector, this works as well as for a weight matrix.
Yeah, weight matrix it will work.
Okay.
Sir, can you just scroll up for 1 minute? I just want to see the loss one. Yeah, okay. A little bit more, just one thing I just missed.
Are you copying or what? Copying is
No. Okay. Actually, I had one question, sir, here. So
Yes.
can I do either way? Can I do features at weights minus labels? That's typically how I calculate it. Will there be a difference?
No, it won't be any difference.
Because we anyway will do a mean square error later and all that stuff.
No, actually it's the square of error, right?
Yeah.
So, it won't affect.
Okay.
Okay, so do this function quickly. Just you need to write this function. Because we have already...
I can show the function, sir. Yeah, I can proceed to the last 9. I think that is gradient descent will take more time, right?
Here only we have one gradient descent equation, then we have to move to perceptance as well. That's why it will take more time now. Okay, so let's move to the fit function here. Okay, so you just need to return this value for these features and labels. If I show that function, so fit function will give you pseudo inverse. So it is x transpose x inverse. So this is pseudo inverse of x transpose x and times x transpose. So times x transpose and times y. So whenever I'm saying times, this is metric multiplication. So this is labels. So this will take two parameters x and labels and will give you the learned weight vectors, right? Now we will calculate value of w for our data set, that is x train and y train. Now check what it comes. Okay. Now I've said w new to this is my w new. Okay, if you check w new, this is my learned weight vectors using the normal equations. If I calculate the loss for this weight vectors that we have learned using normal equations, my loss will come out to be. Now look at the loss function. This is coming very low, low rather than this loss function that we have calculated using the random weight vector. Here it is coming into the thousands. Now it is come to very low. Now if you predict the values for that W new vector, look, you have 1 1 0 1 1 0 0 1 1 and 0 always 1 always. So you can say that it may be good prediction, right?
Sir, I have a confusion in the fit function. Can you go back to the fit function? Here, sir, pseudo inverse itself means x transpose x inverse x transpose, right?
Yeah.
Then when I'm writing PINV, then why am I also writing x transpose x inverse x transpose?
So I'm to take inverse of x transpose x. Look it here. I need to take the inverse of x transpose x.
The entire term x transpose x, inverse x transpose is the pseudo inverse of x, right?
This is the inverse of x transpose x.
Okay.
What I'm saying, if x transpose x is not the pseudo inverse, sorry, not full rank, then you have to take the pseudo inverse.
Yeah, pseudo inverse of x is defined as x transpose x inverse times x transpose.
No, I'm not taking pseudo inverse of x. I am taking pseudo inverse of x transpose x.
Pseudo inverse of x transpose x.
Yeah.
Okay.
X transpose x is again is matrix, right? Okay. I'm not taking the pseudo inverse of x. I'm taking pseudo inverse of x transpose x.
Okay.
Okay. So up to here it should be clear now. So this is your using normalizations. Now go for optimization problem. For this time we have already only for one type of batch gradient descent. You can do the similar way in the similar fashion for mini batch and stochastic gradient descent. Okay. So before going to gradient descent, just define a function gradient or grade that takes parameter features, labels, weights, and calculates the derivative of loss function for the given weight vectors. So remember this formula only. Okay, so derivative of loss function with respect to W is given by x transpose xw minus y. Okay, so this function, I'm just going to the solution here. So gradient takes three parameters x, that is features, labels, and weights, and give you the derivative values. Okay, so derivative will be x transpose xw minus y. So this is your x transpose xw. Okay, so if you multiply it, this is gonna be x transpose y. So minus x transpose y. So this is your this function will return the derivative value. Okay. Should I proceed or should I wait? Now the next task, once we have calculated the gradient, how to update the weight vectors, right? So that's how we update our weight vectors. We differentiate, we subtract the all weight vectors by the alpha times the gradient. Okay. So your next task is to update weights. It takes the weight vectors that needs to be updated with the learning rate alpha, and x train and y train are the features matrix and the level matrix. Okay. So what you need to find? You need to find W minus alpha times this. So what it will return? It will return W minus alpha times gradient of this. I can call this functions now here because I need to calculate the gradient values of W with respect to, I need to calculate the derivative values of loss function with respect to W. So I can call this function here. Okay. Any problem up to here?
No, sir.
Okay, so let's look what we have randomly initialized, right? Some random vector W. For this vector, let's say W1 is the updated vectors from the W, and learning rate I have set to the 10 raised to the power minus 5. And I will use the training data set and training data set. Okay, so this one is W here. So if I calculated the loss function for this W1, again you can check the loss function has come down to some values. Okay, if I set my learning rate to, let's say, some other value, let's say 1. Okay, so what do you think about the loss function?
It should go down a lot.
It'll go up.
It will go up.
Okay, this is too big, is it? I thought maybe it's not.
Yeah, because you have taken more steps.
Yeah, 1e minus 2 might give go down.
Yeah. Right. So minus 5. Okay. So that's how you update your weight vectors. Now you have to find, you need to define a function gradient descent. that text parameters, features, feature matrix, level vectors, number of epochs, and learning rate. And now you have that will function will return you to the learned weight vectors. Okay, and for this you just initialize your weight matrix with 0 matrix. Okay, so should we proceed, or you wanna try this?
Sir, after this, how many things else are there?
This one will be done after this.
Okay, so then we have time to do this then. Okay.
Okay, then we can go for perceptron slides. Okay, here I can only go gradient descent, and stochastic you can do in the same level. Okay, only one changes will be there. Okay, so let's see the solution here. In the gradient descent functions, it takes feature matrix, level output, number of epochs, and learning rate, and it will give you the learned weight vectors. Okay, so initial W vectors I will initialize it with the 0 weight vectors. So W will be np dot zeros. Now in each and every box, how to update vectors? I will just call the update function, right? So it will update my W in every box.
Yes, sir.
Okay, so it will return me the learned weight vectors. So that's how my gradient descent functions work.
Yeah. So silly question, sir. The last thing, the definition of the function, I had not seen it earlier. The returns np.nd array is defined that way with a pointer kind of a function.
Yeah. This just a annotations type thing.
Okay, so it just means that it is returns an np array.
Yeah, function doesn't take care of this. It's just for what outputs you will expect from these functions. Okay.
So it's just for reading. It's not asserted anywhere.
Yeah. Just annotations for this. What other can expect from this function. What output he can expect. Right. Similar manner that semicolon that np array. So x must be x you can think of as a n-dimensional array, right? You can think of as n-dimensional array. The learning rate can be float. You can think as a float value. So similar, the output of this function you can think as a n-dimensional array. Okay.
So sir, even the colon ones are not asserted, is it? If I give an input that does not match, it will not.
No, it doesn't. It doesn't matter. It doesn't matter, right? If you give the integers, it will take the integers. You can remove this as well.
No, but I think if you give not an array, right? If the first two values are not arrays, it will give an error, right? If you just give
it won't. It won't give an error. It's just a annotations. Function doesn't know what function will take its output, whatever the output is. Even if you print something hello, it will give you the print hello, right?
But if it was an equal to sign, then it would give an array, no? Give an error, no?
No, equal to sign, then the function doesn't work. There's
no, sir. Instead of the colon, if it was an equal to, then
it's the default values put it.
Okay, that's a default value.
Default values. If you set the default values, let's say if you set the learning rate to be 0.05. So what will happen if you don't give the learning rate here? Okay, if you want the learning rate here, then it will take 0.5 by default. Okay, now it will work here. If you seek, I think this way. Okay, so in this case, if I have done this, I haven't set learning rate here now, right? So it will take learning rate 0.05 by default. So this is my default values.
Got it.
Okay. So what was here? So this is the weight vector that is learned using gradient descent method. So if I calculate the loss for this weight vectors, I have this much of loss. And if I predict the function, so this was the prediction using W2, and if you can see that prediction using where we have done that. This one. So look, 1101100 something 11011, and here also 11011. So you can check the similar kind of prediction it is giving. Both the methods are giving something similar kind of prediction. Okay.
We are not changing the learning rate here, right?
Yeah, we are not changing the learning rate here. It is constant throughout the method. If let's take only 10 epochs, then let's see what happens. So what do you think of the loss? It's gone higher, right?
Yeah.
So let's set it to be 1000. So it is taking lots of time to go to the minimum point. Okay.
Because you have set the learning rate to be low, right?
Yeah, learning rate to be very low.
Sir, like we did in MLF, is it also possible to assign Taylor series kind of thing to learning rate as default?
Default take, I think adaptive learning rate is taken by default, right? That change if the learning is not happening, that is the loss is not decreasing, then it itself decreases its learning rate by some factor. Okay.
Okay, so but we are not doing that, right?
Yeah, we have set by ourselves by input using given the input, so it will use the same learning rate throughout every epoch.
Okay, sir.
Okay, so last one is very easy, the evaluation part. So for here you have to define three or four functions. One is precision, second is recall, third is recall function, last one is accuracy function. So recall, what is precision? Precision is out of how many that is predicted positive, how many are truly positive, right? So this is precision. Okay. And what is recall? Out of total positive in the data set. So this is your total positive in the data set. How many are truly predicted positive, right? So this is your recall. Accuracy, out of total predictions, how many true predictions were made, right? So this is your accuracy. So how that's how these functions are defined. So what is true positive? Which is predicted positive, and actually that is positive. So so evaluation.
I thought they will take the actual predictions and that, but you've defined it this way, right? Okay.
Yeah. Okay. So now what I will, the evaluation part is done on the test data set. So I will predict the test data set using W1, or you can also do for W2. Okay. Those W1 was my I think let's do with using W2. Okay. So this will give me the predicted values for the test data set, right? So this is my predicted values for data set. So you can check what is how it will look like. So this is your predicted values. And you remember in the test data set you have only 20 examples. So those examples are classified by predicted as 0, 0, 0, something like that. So what is the test data set? Okay, so if you remember here, by test, if you have remember here, by test, where has gone that? Yeah, by test is the encoded one. So we have to convert this into the decoded one. So what I will do, I will just call the argument function here. So it will convert that into the decoded matrix. Okay. And now I will calculate TP, TN, FP, FN. Okay, so I will check whether predicted values and the actual values are same. So the predicted is positive, and if the actual value is positive and predicted positive, then the TP will be added 1. Yeah. So it will take value 1, otherwise it will take value 0, right? If the predicted is negative, and actual it is negative, so it is true negative. So it will take 1, otherwise 0. In the false positive, if it is predicted positive, it is predicted positive. Okay, so 0th class I have taken as a positive class. Okay,
Yeah,
so
we
I
should
made
probably
one-
change it so that it is not
Yeah,
confusing.
yeah. I made one mistake here. Okay, so for now, take 0 as the positive class and 1 as the negative class. That will work or not? Okay, so I think we have to change this. And by test 0, right? This one is predicted negative, and actually it is false predicted. Actually predicted. So what is FP? So it is predicted positive and actually it is negative. So then it will give 1, otherwise 0. So that's how you can calculate TP, TN, FP, FN. So if you call recall here, recall will come out as to be 1. So what does it mean? What does it mean?
It means that the ratio.
It means that all the positive examples are correctly called.
Yeah, correctly predicted, right?
Yeah.
If you call precision here, so let me call precision as well. What parameters it takes? TP, FP. So if you call precision, so precision is again 1. What does it mean?
All the positives that are predicted.
Positive are actually positive.
Yes.
Are actually positive.
Yes.
And what is accuracy?
Accuracy should be also 1.
What is takes parameters? Accuracy is also
Yeah, because
this,
recall and precision are 1, I think accuracy should be 1, right?
Yes.
Yes.
But does it internally have some kind of relationship when we are using random? Is there a linear relationship which explains why we are getting such?
Are you making any mistake here in defining TP, FP?
No, I don't think so, sir.
No, sir.
So our model is so accurate, is it? Yeah, it's because it's a very look at the data set.
Small loss also.
Look at the data set here. It's very separable, right? This one.
Yes, sir. Yes, sir. Very separable.
Yes. Yeah, so it is linearly separable. So you will find very good that linear discriminant function in this case. That's why I think this is happening. If we have made a mistake. Okay.
Yes, sir. We defined it very well.
Sir, can you just show me the sample creation once more? I missed that part.
Which one?
How the samples were created. Is it because of the +1, -1 that they are so well separated?
This one you're talking about.
Yes, yes, the samples.
Yeah. So this thing, right? So these collabs are provided to you or not?
I don't think so, sir.
No, sir.
Solve with instructor slides are being provided or not?
No, sir.
No, sir.
Not yet, at least.
Okay. We'll check with the team we are planning to provide or not.
Okay, sir. It will be very helpful for us, sir.
Sir, are you not going to cover the rest of the visualization part?
No, not in this visualization. We will do in some separate session. Okay. So should we move to perceptron now?
Yes, sir.
Okay, so in this I have skipped some part like many events, gradient descent and stochastic gradient descent visualization, and also you should try all this for this data set. Okay, whatever you have done by now, you can do for other whatever we have skipped. Okay, so now let's move to the perceptron. So can you see this perceptron column file?
Yes, sir.
Perceptron is rather easy than Instructor. Okay, so first task is the same that we have done here. We have set both classes, first class from -1, second class from +1, and always remember perceptrons only can be done only binary classification and only for linearly separable data. Okay, so for first task is to create feature matrix and level vectors and create the data set. So that we have already done for list listed classification. So I'm just doing it quickly. So random seed I have set to one number, x1 the same thing. Now mean I have set to -3, right? And for second class I've set mean to be 3 at 0.3, and the same 50 data points for each to plus. Okay, so x will be what my the same thing that we have done. So this is my feature matrix x now. Now labels, come to the label, positive labels. I have 50 labels from the class -1 and 50 from the class 1. So positive as ones, 50 ones, and then 50 -1s. So this is my -1, NP zeros -1. So this is my negative class. So if you remember in the X, first are coming from the negative class and the next 50 examples are coming from the positive class. So for pi I concatenate negative labels and positive labels. So this is my label matrix pi. For the perceptron, you need not to convert into the encoded matrix. Now you need to add the feature matrix. So you can do the similar manner we have done in the previous way. And one more method is there. You just create a matrix of 100 cross 3, right? Now this is matrix that each and every element is 1 here in this case because it is NP not ones. What I will do, I will just change the second column and the first column and the second column by the X. Okay, so this is my dummy features with each and every examples, and from the from first column to the last column, that is from first column to the second column, I will replace this with the X matrix. Okay, so this will be my X train now. Okay, now I'm not separating into the training data set and test data set because for this collab I'm not going to do evaluation part. So if you want to do evaluation part, you can split this training data set, this data set into training data set into test data set. Okay, so I'm skipping those that part as well. For scatter plot, the same thing. So if you look at the data set here, so these are coming from the two data set, and you can see that those data set are linearly separable. So now we can apply the perceptron here. Okay. Now here we have used use of C1 library. So what this function does, you have to take the data here and you have to assign which will go for x-axis and which will go for the y-axis. For x-axis, I'm taking the first feature, and the y-axis I'm taking the second feature, and they are separated using the labels. Okay, so that's how this functions work. And up to here only this was something not done in the previous slide, previous collab. So I think you all got this one, how this function is working. Okay, so now what is model? You just take the linear combination of these. So this is your again what is this? This is just a surface hyperplane. right? If we are on the positive side of the hypersurface, then we will call it, we will predict it to be positive class. And if we are other side of the hypersurface, then when hyperplane, then we will predict it to be negative class. This is our activation function G. Okay. So what happens in the perceptrons? Every time we just calculated the number of, we just find out which points are misclassified and which are classified correctly. Okay, and we change the weight vectors only for those examples for which it is misclassified. Okay, so that's how the class perceptrons works. So your task here is to predict. You have to define a function predict that is 2 parameters, picture matrix and weight vectors. Okay, and that return the predicted level for that feature matrix X. What is this? This is just XW, right? XW, and prediction will be what? If it is positive, then it takes value positive, and it is if it is negative, then it takes negative. So how you will define this function? I just calculate XW. If it is positive, if Z is positive, then it will give you 1. Otherwise, it will give you negative -1. So it will give you the prediction for feature matrix X and a particular weight vector W.
Sir, how are you sure that Z will take values like that? How are you sure that all values are not positive?
No. This function, what this function does, it will check if Z is 0. If Z is greater than 0, then it will give 1. Otherwise, it will give -1. It is a column. It will give you a column vector.
Yeah, I'm asking you how you're sure that there will be some negative values in Z.
No, if there is no negative value, then it will give you the only 1 for all the values, all the index.
Okay, I didn't get this. Did we made the sample and the weight normally only, no? So all values will be positive here, right? Can you just print X and W maybe?
X and W. X can be negative as well. X I'm taking with the center -3. One data set I'm taking at -3, mean -3.
Okay, got it. Okay, sir.
Even if it is all positive, then your weight vectors can be negative as well. Your initial weight vectors can be negative as well, right?
Yes, sir, got it. Can you show me that once more, how X was made?
The feature matrix X.
Yes, sir. Okay.
The same manner we have done for least square classification problem.
Okay, got it. Thank you, sir.
Okay, so this function is clear to you?
Yes, sir.
Okay, so now what's loss function here? If it is correctly classified, then loss error is 0. If it is not correctly classified, then it is 1. Remember, this is 1 always, because by I is the 1 or 0, and again the activation function of this combination is again +1 or -1. If they are incorrectly classified, they are so sign of by and this thing will be opposite sign. So minus will become +1. So error is 1 for the misclassified point, and error is 0 for correctly classified point. So actually, if you take, yeah, so this function can be rewritten as in this format. If you have seen the lectures, then you can figure it out how this function is same as this function, right?
Yes, sir.
Okay, so let's move to the next task. Task is the you need to define loss functions for the above model. Okay. So what will be the loss? You just need to write this function. You just need to return this function for x, y, and w. So it will take 3 parameters x, w, and y. and this will give you the just need to rewrite this function. So how you will write this function? So look at it will check the maximum of this minus this and zeros. So I will create a 0 vector and this vector, right? I will check where the maxima is occurring. So it will give you the maximum values for those. Okay. If it is 1, then it will give you 1, 0, it will give you the zeros. And the sum of all those. So it is actually number of misclassified points. The error is number of misclassified points. Just have a look at this function and let me know if is there any problem in this function. Okay. So what is the optimization procedure? If it is correctly for a particular example, if it is correctly classified, then we don't change in the weight vectors, because if pi I and pi I is the same, that is it is correctly classified, then the weight vectors we don't update any weight vectors. But if it is incorrectly classified, we just update the vectors by the by this much of factor. We add those values. Okay. So you for this, how this is working, you can see the lectures. So your next task is to, what is the task here?
Sir, I did not get the weight update.
So just give me a minute. I just show you something.
Okay.
Hello, sir.
Yes.
Yes, sir. I just wanted to clarify something.
What?
So we have something called as a bonus mark.
Bonus mark for what?
Bonus mark for our entire like they have added a new feature called as bonus mark. Do you have an idea about that, sir?
Yeah, for if you are attending live sessions or answering on the Discord forum, then you have been given bonus marks, right?
Yes, sir. So there's also another for practice assignments. I just wanted to know if the practice programming assignments are also included in that.
No, practice assignments are not for grading.
No, we have another bonus mark for practice assignments as well, sir.
So about that, I have no idea.
Okay, sir.
So can you see that that book here?
Yes, sir.
So for a particular time, your hyperplane is something like this. Okay. So if you have seen the lectures, you have you know that weight vectors does information about orientations of the hyperplane, right? W0 give the distance from the origin, and the weight vectors give you the orientation of W, right? So let's say for a particular epoch, your hyperplane is something like that. Okay, so this so this one is misclassified, right? Which all these so all these are misclassified. So this is actual classification. This is your positive. This is negative. So look at this thing. Upper side, this all 4 are misclassified.
Yes, sir. Yes, sir.
And here these 2 are misclassified.
Yes, sir.
Okay. So what it will do, it we update the weight vector in such a way that it tries to take misclassified point to the correctly classified point. Okay, so the next thing, it will be, if we update the weight vectors, then the next weight hyperplane may look something like that.
Sir, I didn't understand how you updated the weight. So the red lines are what?
It's the in the direction. Look at here.
So the black line is the initial weight vector, is it?
Maybe it at some epochs, not the initial. Okay, it may be at some different epochs.
Okay. So weight vector is just a vector that is perpendicular to the decision boundary.
Yeah. Depending on orientations of the weight vector. So let's check what the updation tool here. Yeah, so this is your updation tool. If the for some example, if it is correctly classified, then we don't have the weight vectors. But if it is misclassified, let's say it is negatively misclassified, and that is actually it is negative class and classified as +1. So this what we will do, we will just differentiate the linear combinations. Sorry about that. So we just take the linear combination of that polynomial transformation of x vector and just the difference, take the difference from the odd weight vectors. Okay, so this is the classification for negative class. If it is positive class misclassification, we just add those this feature matrix to that weight vector. So what actually we are doing, if you see this thing. So let's say this one is misclassified. Okay, so what we'll do, we just try to change the weight vector in this direction. So what will happen? This plane, this will try to move in this direction, in the direction of x, this point. Okay, because we have changed our weight vectors in this direction, right? In this direction, we have changed our weight vectors. So this plane will try to move in this direction. I think sir has also shown this like this thing. See this icon. If this is wrong, then our we will change our weight vector in this direction. So the plane and itself will try to move in this in that direction. Okay. If it is wrong, now look at this. This is wrong. Then we will change the weight vectors in such direction. Then it will, the plane itself will try to cover those points into the correct correct class. Okay. So depending upon how you have started your weight vectors, it may take longer time. It may take less time depending upon how you have started your weight vectors.
Sir, does this only adjust for the weight vector, or does it work with bias also? So, like, is
Yeah,
the
bias also. Let's say you have started your plane somewhere here, somewhere from 0 to 0, passing from 0 to 0. So you have to move that plane upward, right?
right?
W0,
Yes, sir.
W0 gives you the distance from the origin.
Yes,
Right?
yes, sir.
So let's assume you have started your plane from somewhere below to both classes. Then you have to move your plane upward as well.
Right, yes, sir.
Yeah, so in that case, your W0 will also update.
Okay, and the sign of the update vector is decided basis
Depending upon whether it is of positive class or negative class.
the misclassified point is from the positive or negative. Okay, sir,
Yeah.
got it. Thank you, sir.
So okay, so I missed the writing the task here, but your task is to just optimize your weight vectors, right? So you have to train your data set. You have features matrix, level vectors, number of epochs, and by default now this has been set to 10. Okay, if you won't give the training function any epochs number, then by default it will take 10 number of epochs, and learning rate has been set to be 0.01 by default. Okay, so initial weight vectors I have taken as, yeah, so initial weight vectors I have taken as 0 weight vectors, and for every time in the number of epochs, so this will iterate your number of iterations time, number of epochs times. So initially error is 0. And for xi and target in the j function, so what this function do is just take the tuples of these values. So first value is coming from x and second value is coming from y. So xi will come from x and target will come from y, right? So how many error you will add? So just leave about the error. We are interested only w vector. So how w are updated? W are updated using w plus alpha times by I minus by I at into x size. So that's how w are updated. Okay. Target. Remember this. This is your target, and this is your updated. This is your predict value, right? This is your target, and this is your predict value. So I call predict function here, and x size is the example. Okay, this feature. And when we will return the w, when the loss becomes 0, right? When loss becomes 0 means that all the points have been classified correctly. And remember, perceptrons will always converge. If the data points are linearly separable, then perceptron techniques will always converge.
But sir, you will not know in advance, if the data points are linearly separable.
Yeah, that we cannot sure about. That's why this technique is very used very less in behavior. Okay.
Okay.
So it will give you two things: the w vectors and error. Yeah. So for our training data set, we can say WR. So this W has been learned using the perceptrons method. Okay. And if you predict the on the training data set, then you can see first 50 are coming from the negative class. That is all, and next 50 are coming from the positive class. That is all the examples are being correctly classified. So that's it from today's session. I think you all got what we have done for this. So any questions till now, till this point?
Yes, sir. So for perceptron, we need not have any evaluation method, no?
No, we can do evaluation. If you want to evaluation, you just do the you split your data set into training data set and test data set, and then you can do the evaluation on test data set.
But it'll anyways be all correct only because
correct only for feature matrix. What if you will another examples come, right? We have only some examples from our data set, features data set. What if a new examples comes? So evaluation tells you whether if the new examples comes, then how that models works.
So when the new examples will come, the perceptron will again move, is it?
If it is in the model is correct, learned correctly, then it will give you the right prediction.
Okay, so we need not train it on the test set again, and we just have to evaluate.
No, we don't train on the test set. We only evaluate on the test set and train only on training set. That's why we divide our data set into two parts, into training set and test set. Test set is unknown for the model, right? We have done learning only on training data set. The test set is unknown for the model.
Okay, yes,
so
yes.
It's a new example for the model now.
Okay, got it.
Okay. So I think we can close the session now.
Yes,
Sir,
sir.
Sir, yeah, just regarding that practice programming questions,
Okay.
I mean the practice ones, I'm not talking about the graded one.
Okay.
So can you provide the solution code for that? Because it's not really, not able to see it.
Which question?
I think for all of them, it's not given actually. That's one another reason I'm asking. If you can just take a look at it later on.
Okay, let me just show you that. Can you see the screen?
Yeah.
So this is your first exam, first question. Here you need to define a function confusion matrix that gives the TP, NP, F something this TN, FP, FN, TP, right?
Yes, so what I mean is after the deadline is passed, if you could also give a solution code as you're done for a graded one, that would be very helpful.
Okay, so that I will convey to the team.
Okay, and the test cases are the same, right, sir? The test cases
Are the?
I mean, this is exactly what you're giving as input, right? Just wanted to confirm.
Yes, same for everyone. Yeah, it's same for everyone.
No, I mean, it's not a code of sort, right?
I didn't get your point.
Okay, no. So basically, you're giving the function 1, right? In that case, whatever was that test case, if the test case is saying 1, then you're giving the function parameter 1.
Yeah, that is happening internally. That I need to check what's actually happening there. Okay, so outputs may be different. It's not that output is 1 or input is 1.
Okay, so sir, if possible, can you give the proper test case? Because that's
No, that is not possible. We are not the test case, but actually the inputs for the test cases is okay. So actual output and expected output is on there, right?
so if I have missed a few practice questions last week and I want to do it again, like I want to practice. So,
but questions is always there, right?
Yes, sir. But I'll write a code, but to test if I've done it well or not, I'll require test cases, right, sir? That is why.
So just write code there only in the portal and check whether you have done correctly or not.
No, sir, I can't submit it once the deadline is passed. That's why I'm asking, sir. Can't submit.
For the graded.
I mean the practice one, sir. For the
practice ones also you cannot submit after the deadline.
No, sir.
Okay, then that's the issue that I have to check.
And if the submit is enabled, not a problem, sir. Then it's.
Okay, so I will check with the portal team. If we can enable this, then we will try to make it.
Yes, sir.
Enabled.
If that's done, it's great, sir. Because I also don't want to go inside the input and find the test case. If that is enabled, it will be really great. Because sir, I've missed a few questions and I want to practice it. That's why I'm asking, sir.
Okay, I will check with the portal team. Okay, yeah, I can see you cannot submit it again. Okay, I will check with the team. Okay.
Thank you, sir.
So I think we can close the session now.
Yes, sir.
Thank you, sir.
Thank you, sir.